Okay, so today we're going to be talking about absolute value with inequalities and graphing the union of the solution. Right, so we talked about solutions, we talked about inequalities. Let's look at absolute value in inequalities. And today your language objective should be that you should be able to describe how the graph of the union differs from the graph of an intersection. Let's start with this example. To avoid turbulence, a pilot must fly above 4,500 feet or below 3,000 feet. So, keyword here, above 4,500 or, actually let me change my ink on that one. Let's do above 4,500 feet or below 3,000 feet. And the keyword here would be or. So how could I use this number line to represent 4,500 feet and 3,000 feet? Well, obviously 3,000 is less than 4,500. So let's put 3,000, I don't know, say right here. Because that represents 3,000 feet. And over here, let's see, 32, 34, 36, 38, 40, 42, 45. Does that look that way? It doesn't matter. Let's just put it over here. So this should be a little bit more mathematically exact, but for this purpose, it really doesn't matter. Okay, so how could I plot 4,500 above 4,500 on this line graph? Well, first of all, we'd have to draw a circle stating that that's where we're looking at, and above would be in the positive direction. Now, would I shade this circle in here, or would I leave it open? Let's go back and look. A pilot must fly above. Does that mean the pilot is flying at 4,500 feet? Or does that mean not 4,500, just above that? And I think we can say that it would not include 4,500 feet. And this is specific, right? I mean, you do not want a plane, if it's not supposed to be flying at 4,500 feet, it should not be flying at that height. It needs to be above that. So we would leave this circle open. All right, what about less than 3,000 feet or below 3,000 feet? That would look something like this. So let's look at the situation in a little more familiar stance. But before we do that, okay, so let's go back to this example that we did, I don't know, a couple days ago. So, we talked about absolute value with this. And this picture looks a little bit different. So how could you briefly describe the meaning of this line graph? And it says, be ready to share your thoughts with the rest of the class. So just take a second to think about what this could possibly mean. We talked about that sentence frame a few days ago. And the sentence frame was, the difference between x and 0 is 5 units. Remember that? We talked about the difference between x and 0 equals 5. And we could have written that the absolute value of x equals 5. And that would represent this 5 and this 5. But this time, the difference between x and 0 isn't 5 units, it's above and beyond that. So we would, instead of writing this, the difference between x and 0 is equal to 5, we're going to say greater than 5. Or the absolute value of x is greater than 5. Okay, well, let's just examine this a little bit further. So here's our topic. Absolute value greater than. So we'll get back to exactly why it says GreatOR in a second. So let's look at this one. The difference between distance. The distance between x and 6 is greater than or equal to 5. So that's basically saying the distance between x and 6 is greater than or equal to 5. Well, the way we would solve this is by looking at x minus 6 being less than or equal to 5 in the negative direction. Remember I talked about that? That if we're going this way on the number line, it would be in the negative direction. And x, the distance between x and 6 going in the positive direction. That's how we put these two inequalities up, or before it was equations. But can you see a difference between these two? Well, let's talk about it. First of all, let's solve. We'll just move that right there. Okay, so if I were to add 6 to both sides, I would get x is less than or equal to 1. And if I were to add 6 to both sides of this inequality, I would get x is greater than or equal to 11. So let's see if that makes sense. I said the distance between x and 6 is greater than or equal to 5. So on our previous examples, we would start at 6. I'm going to go over to 6. And we would go 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So I have 1 and I have 11. But this is saying x is less than or equal to 1. So that means, and I'm going to shade it in because it says or equal to, that would mean I'm going in this direction. And if I were to say, but x has to be greater than or equal to 11, that would be, once again shaded in, and in this direction. Let's go back and look at the fact that these signs changed. Change to circle. Okay, so from here to here, when we talked about going in the negative direction, if you notice, this is saying greater than or equal to, and this is saying less than or equal to. So why do you think that when I'm talking about going in the negative direction, I need to switch the sign? Well, let's see what would happen if I didn't. If I didn't switch the sign, it would say x is greater than or equal to 1. Okay, let's look at that. So it would be going in this direction. Correct? Well, what does this say? This says the distance between x and 6 is greater than 5. So if we have a distance between x, well, when x is going in this direction, x is 1. So the distance between 1 and 6 and the distance between 6 and 11 is greater than or equal to 5. Well, if this right here is the distance between x and 6 in the negative direction, and this is the distance between x and 6 in the positive direction, both of these values need to be greater. The distance has to be greater than 5. Greater than 5 and greater than 5. Well, if it has to be greater than 5, then it needs to be above it. The distance has to be above it. And the distance over here has to be above it. Well, if I would have left my sign as greater than or equal to, it would have included all these values, which aren't correct. So that kind of gives you an explanation of why you have to switch that sign. So we're talking about the distance being more than that. Here's my distance. Here is the solution of it being more. Is 0 a distance more than? Yes. Is -1 a distance more than? Yes. And when we check our solutions in just a little bit here, that'll make more sense. So let's continue. Let's do this one in a more traditional way. So my first step is to set up two what? Two equations. So I need 2x plus 8, that is, I should actually put this one on the right-hand side. 2x plus 8 is greater than or equal to 6 in the positive direction, and 2x plus 8 is not greater than, but less than or equal to 6 in the negative direction. So next I'm going to solve for both of these. So I'm going to, first step is subtract 8 from both sides, and I get 2x is less than or equal to, I've got a negative and a negative, so combined they make negative 14. And when I divide both sides of this equation by 2, I get, if 2x's are negative 14, or 14 negative, then 1x is less than or equal to negative 7. Over here, take 8 off of each. Inequality. I'm trying to have a, not doing that anymore. And 2x is greater than or equal to, I have a negative 8, positive 6. 8 negatives is larger than 6 positives, so negative 2. And when I divide both sides by 2, I get x is greater than or equal to negative 1. I'm going to go ahead and graph that and make sure this makes sense. So I have x is less than or equal to negative 7. So here's negative 7 is less than or equal to. Let me go ahead and fill that in and go in less than direction. And x is greater than or equal to negative 1. So here, and 1 greater than. Let's go back and look at our original inequality, or absolute value inequality. 2x's plus 8 is greater than or equal to 6. Okay, well that's saying that if I have 2x's, then the distance between 2x's and negative 8 is greater than or equal to 6. Well, we learned a couple days ago that if we're talking about 2x's, if we split everything in half, then we won't be talking about 1x. So x, the distance between x and negative 4, so here's negative 4, so the distance between x and negative 4 then would be greater than or equal to 3. Well, let's what? 1, 2, 3. Is the distance greater than that? Going in the positive direction? Yes. And the distance in the negative direction? 1, 2, 3. Is it greater than or equal to in the negative direction? Yes. So this definitely works. So I'm going to say the solution set is, and this is put in just called set notation, x such that, so it's saying, basically it's fancy way of saying, we're talking about x. X is less than or equal to, less than, right here, negative 7, or x is greater than or equal to, which is right here, negative 1. if this makes sense. I think this makes more sense than actually checking our solution. But we could definitely check our solution. So might as well be thorough. Let's look at a number that's, I don't know, over here. Actually, the easiest one to do would be talk about something that shouldn't be a solution and see if that works. Let's do that. Let's use this equation over here. So I'm going to say 2x's plus 8 should be greater than or equal to 6. And let's say I pick the value of -4. 2 times -4 is -8. Is -8 plus 8 greater than or equal to 6? Nope, not even a little bit. 0 is not greater than or equal to 6. So that is not a solution. And that's good because we didn't say it was. These are our solutions. Anything above here or anything below here. So that definitely works. Let's try another one. Let's set up two equations. So I've got 2k's plus 1 should be greater than 7, and 2k's plus 1 should be less than -7. So in order to solve for this, I'm going to subtract 1 from both sides. So now I have 2k is less than -8, so k is less than -4. Take a 1 off each side. 2k is greater than 6, so 1k is greater than 3. No room on this one. Alright, so let's move these up. So I've got k is less than -4. Here's -4. Less than, not equal to, just less than would mean everything on the number line below -4, and k being greater than 3 would be everything on the number line above 3. Those are our solutions. K has to be, oh shoot, look at, I have less than or equal to there, and that is not right. So let's just alrighty, so k is less than -4, or k is greater than 3, are our two solutions. And let's solve, and let's stick 0 in there and make sure that it does not work in here. I'm going to say 2k plus 1 is greater than 7. 2k's plus 1 has to be larger than 7. If k was 0, I would get 2 times 0 is 0. I would get 1 is greater than 7. And that's not true. So none of these values in here would work, and we graphed this correctly. Let me just change this. Keep the students working together. Take that off of there. All right, let's talk about these two inequalities and compare and contrast them. Okay, so let's start with example number 3. Difference between, or the distance between r and 6 is greater than or equal to -5. Okay, well, first of all, we know with absolute value, distance can never be negative. Okay, so whatever the distance between r and 6 is, it's not going to be a negative number. But this inequality tells me that whatever the distance is, it's greater than this. Well, it has to be greater than -5 because -5 doesn't exist. The distance can't be negative. So in this case, the distance between r and 6 would be greater than, well, if this is not possible, it would be greater than 0. So let's look at that. The distance between r and 6 has to be greater than or equal to 0, and the distance between r and 6 has to be less than or equal to in the negative direction of 0. Correct? So that would be 0 in both cases, and it would be all the numbers going greater than and all the numbers going less than. So the solution of this is actually, we're talking about the distance between two numbers being greater than this, which doesn't exist, then it's all real numbers. Let's look at this one. The distance between 2c and 5 is less than -3. So again, can't have distance being negative. So let's look at this comparison. Distance between 2c and 5 is less than nothing. And the distance between 2c and 5 is greater than nothing. Well, that doesn't work as well because you can't say it being greater than, and then it can't be less than. And maybe that wasn't a very good comparison. Okay, stop for thinking about this for a second. I'd have to say that writing it out this way, not as good. Let's think about it differently. Let's think about it as the distance between r and 6 has to be greater than or equal to something that doesn't exist. So the distance being greater than nothing would be everything. Because you can be greater than nothing, but you can't be less than nothing. So less than nothing would be absolutely nothing. That makes more sense. Sorry about that. I thought separating them would work, but doing it in this example is very confusing. So greater than nothing, everything. Less than nothing, nothing. Hopefully that clears that up.